In 1959, writer Howard Bloom came up with a theory that the universe was actually much smaller than we initially thought and was shaped like a donut. He himself admitted that his theory was more of a perfect idea for a comic book series, but recently some of his assumptions were confirmed. And if all these teenage fantasy stories turn out to be true, the end of the universe will come much faster than we thought before. Is it so essential for us to determine the universe's size? The point is that our future depends on it. Spoiler alert. Unfortunately, it seems that none of the scenarios are optimistic for humanity so far. If the universe is too big to ever be measured, we're probably all in for the big freeze. Scientist Michio Kaku claims that as the universe expands, it'll start slowly cooling down.
Another possibility is the big freeze, that the universe expands and just keeps on going, and we're all going to freeze to death, and we're all going to die when the universe reaches near absolute zero.
This means that any life, if it exists somewhere else apart from our civilization, will simply freeze. However, if our universe is slightly smaller, at some point it'll stop expanding and we'll actually reverse this process. Everything will go backward to a compressed spot and end with a new Big Bang. But what if the universe is endless? Unfortunately, even a potentially infinite universe won't have a very happy future. In a few billion years, all galaxies will move away from each other so much that the universe will just vanish, leaving behind only scattered celestial bodies floating in an absolute vacuum. It doesn't seem that terrifying, though. We won't get distraught if we don't see the nearest galaxy in a telescope, right? However, it's a bit more complicated. If cosmic connections cease to exist, atomic connections will disappear as well. Scientists call this possible outcome the Big Rip theory. When dark energy becomes stronger than gravity, everything will be literally torn apart. But can we somehow prepare for the end of the world? What prevents us from determining the size of the universe right now? The Hubble constant has been giving a headache to many scientists over the years. This exact number can tell us how fast the universe is expanding and what size it is. The constant got its name from University of Chicago graduate Edwin Hubble, who was the first to calculate it in 1929. Despite nearly 100 years of astronomical measurements and calculations, scientists still can't agree on the exact value of the constant. Edwin Hubble claimed that the number was 310 miles per second per megaparsec, while now astronomers tend to push a range of values from 42 to 46 miles per second per megaparsec. What an impressive fluke, isn't it? But what is this controversy all about? The problem is that there are two ways to measure the Hubble constant. In the first one, we study how fast nearby galaxies are moving away from us. And in the second one, we record the cosmic microwave background. Ideally, these two features should match, which is implied in the standard model of modern cosmology described by Alexander Friedman. But the Hubble constant values don't correspond in any way, which means that one of the methods to calculate the constant might be flawed, or that we know absolutely nothing about our universe. Though it's not only the Hubble constant that prevents us from determining the size of the universe, the latter also depends on its shape. But do we know the shape of the universe? What the universe looks like directly depends on one parameter of its density. Around 68% of the universe consists of dark energy, while another 27% is dark matter. The rest is ordinary matter that planets, stars, and other celestial bodies are composed of. The density of the universe is measured by how much of this matter is packed into a certain space volume. Most astronomers assume that the density of the universe is normal, meaning that the amount of packed material is equal proportionally and restrains the expansion of the universe. Thus, the universe isn't curved anywhere. It's flat and infinite. But how in this case can we find out its scale? What is the size of infinity? It was in 2019 that the scientist Alessandro Melchiori got really close to answering this question. He discovered that the density of the universe was large enough for its gravity to overcome the force of expansion. Consequently, the universe has long been curled up into a ball. Such a scenario would be ideal for determining the scale of the universe. After all, it's much easier for us to measure the volume of a ball than the volume of a shapeless, endless nothing. But in the scientific community, Melchiori's assumptions haven't been confirmed yet. Ironically, the donut universe theory that I jokingly mentioned at the beginning of the video received some evidentiary support. In 1998, a researcher named Adam Rees published the results of his calculations, and they don't correspond to any of the theories known today, except for the donut universe one. Unfortunately, experts haven't come to a consensus even on this issue. So, can we really trust any data about the size of our universe at this point? Firstly, everyone knows that all information we get about space is an echo from the past. Light takes hundreds, thousands, millions, even billions of years to reach our telescopes. Even from the star closest to us, leaving out the sun of course, the light from Alpha Centauri takes 4 years to reach us. So everything we see now is the chronicles of the past. And over this period, the universe might have already changed several times in fact. Secondly, perhaps we still can't find answers because the universe isn't what we imagined at all. Looking from Earth, it's sometimes difficult to understand that, in fact, our planet is round. And a couple of centuries ago, you could even be sentenced to an excruciating death for such statements. Astronomer Rachel Beaton draws an interesting parallel. The speed of a car changes if it goes up or down a hill, even if the driver presses the gas pedal the same way, right? Maybe our data on the size and shape of the universe don't line up because that part of space where we live is somehow different from everything else. What if the universe isn't really shaped like a sphere, but say like ruffled sheets or a mountain range? Anyway, while scientists keep arguing, NASA's made some astonishing statements out there. All we can truly conclude is that the universe is much larger than the volume we can directly observe. Sounds reassuring, doesn't it?
I understand nothing.
And what about you? How big do you think the universe is? And will humans ever be able to predict its future?